Well, hey there, it's your old pal, Mr. Cook. We are doing the second part of this uh, test review worksheet. I guess the next four problems. So we've got to do disk method for all of these. Disk method's pretty easy to work through. The hardest part is if you have to if the graph is offset from like an axis, like the x-axis or the y-axis. But it's typically pretty easy to work through. Couple pointers on this stuff. Let's see. Step one. You are always going to want to graph out your expression in your system. It gets you points. Might as well just graph it out. Number two, find any intersection points or corner points. Use your calculator or solve it by hand. Again, your choice. What else? Oh, probably third step is to determine if it's going to be if you're going to be using dy or dx for your integral. And then fourth step is to just plug it into your integral. Like see if you how your volumes are going to work out if you need to do a washer. In other words, like subtract volumes. But basically, like each of the integrals are going to go something like this: your boundaries on your limits, and then it's going to be pi times some function, your radius squared, and then d, and then either your x or your y variable for the radius. So that's like basically how it goes. Okay. All right, so here's how I put these together. I graph it all out first, so let's graph these out. We've got x squared, y equals 4, and x equals 0. So let's take a look at how that goes. Let's see, number 5. So we've got and where am I rotating this thing around? The x-axis, okay. So around the x-axis. So we've got the parabola, so something like that. And then, let's see, y equals 4. That'd be like up here somewhere. Y equals 4, y equals x squared. And I thought I had a third one. X equals 0. So x equals 0 is y-axis right there. So that means that our shaded region's in here, like this. And then it looks like we are rotating around the x-axis. That's like good news for us, because when it's rotating around the x-axis or the y-axis, things are pretty easy. So here we go. Here's where we're rotating this thing right around the x-axis. Okay, there we go. So it kind of looks like this. Okay, so it's like that, and then like it goes, rotates here. So like it kind of goes like this. It's like this shaded region, and then it like rotates around like that. So this is what it looks like. It's basically like a cylinder on the outside, and then it has like this like cup that's like kind of taken out of it like this. It's like yeah, kind of like that. Okay. So imagine that it's like a cylinder on the outside with like something missing on the inside. Okay. Um, and whenever you have that situation where you have like a shape on the outside and a shape on the inside that's like taken out of it, it's the washer situation. So here's how I like to imagine it. It's like I've got this cylinder on the outside. Okay. So what I'd want to do is find the volume of that cylinder. And then what I would want to do to find this shape is then subtract away like this weird kind of I don't know what you'd call it. Like, I don't know what it's like. What this shape looks like. I don't know, like a trumpet or something, or a horn or something like that. I don't know. But I'm gonna take this trumpet shape, okay, and I'm gonna take it out of this thing. So what I'm gonna do is I'm gonna subtract it out, and what that'll do is it'll give me like a cylinder with like that piece missing in it. Okay, so like it's kind of like hollow inside like that. Okay. Okay, so that's basically what I'm going to do. I'm going to set up two integrals, and then I'm gonna subtract them. That's what this problem calls for. So here we go. Let's do that. So let's find the volume of the cylinder first. So using the disk method, we do the following. We start our bounds. Oh yeah, I should probably determine if this is going to be dx or dy. So if you have the disk method and it's over a horizontal line, you're automatically going to be using dx. Okay, that's like how I like to think about it. And so for this outside shape, this cylinder that we have, like outermost shape, the cylinder, it's going to have a uniform radius all the way through. So the radius is going to be like this length all the way through it. It's going to have a length of 4. So the radius is 4 squared. And then it's going to be times pi. So pi times 4 squared. And then along the x-axis, let's see, where does it go from the x-axis? So it like starts at 0, and then it ends like over this intersection point. What intersection point would that be? That'd be like, let's see, it's where this line and this line meet up. So x squared equals 4. That'd be 2. Yeah, so 2. So along the x-axis, it goes from 0 to 2. There we go. And that's our outside shape. That's our cylinder. Now we got to subtract away this like horn shape. We have an integral. It also goes from 0 to 2. It's also going to be dx. And it's going to be pi times some radius squared. And the radius that we get for this inside shape is going to be based entirely off of this function here, x squared. So x squared is what goes in there. There we go. There's our volume. That's as easy as it gets. So you can just leave it directly like that. You don't need to simplify it or evaluate it. That's the volume. Okay, there you go. There's our first one. Now let's do another disk problem. Let's see what the next one looks like. It's e to the negative 2x. Okay, so that looks like this. It's like goes through 0, 1, and then it like kind of just goes like this the rest of the way. Straighten that out a little bit. And there we go. Okay. And then what's the next one? 1 plus x. All right, let me see. What's that going to look like? 1 plus x starts here at 0, 1. And then it goes like kind of like just with a slope of 1. So like it's a line like that. So y equals x plus 1. This one's y equals e to the negative 2x. And then we have to have a third one, right? Yeah, x equals 1. So let's see. I guess x equals 1. I can just like put that right here. Doesn't really matter. There you go. X equals 1. Looks like the shaded region in between is going to be like this region here. Yeah, that's definitely going to be it because that's in between all three of the graphs. Okay, so let's see here. Then it's going to be about the x-axis. So the x-axis, that's this guy here, x-axis again. And it's rotating around there. Okay, so let's see. How is this shape going to look? It's going to be like, all right, a little bit more like that. There we go. And then the line is like here. Oh, that's not good. That's on the same slope. That's better. And then this line, x equals 1. There we go. So it's like this shaded region. Okay, so it looks like this is another washer problem. Looks like we went kind of heavy with the washer problems. This is also going to be dx because it's a horizontal line. So I have like an outside circle, for my washer, and then an inside circle. I just need to subtract those. So here's how the shape basically looks, okay? Like this outer green shape, this outer green shape here that we have, if we were to like rotate it around the axis, it looks something like this. It's like it's two straight lines like this, and then like I don't know, kind of like a bowl, but the thing is completely filled in. Okay, it's kind of like gosh, I don't know, like a cone, downwards with like the bottom part cut off. And then we've got this other shape, here, right? That and it kind of like looks like this. It's okay, passes through there, and then it like goes up like that. So it would look like this if it's rotated around the axis. Okay. And it's also like it's hollowed out. So basically, what we're doing is we're taking this like bowl, this filled in shape here, this bowl, and we're subtracting away this like I don't know what that is, like a stopper or something like that. We're just like taking it right out of there. So if we do that, if we take these away from one another, here's the shape that we end up with. We get like this bowl thing, right? That we started off with, but it's hollowed out. and this is how it's hollowed out. It's hollowed out with this thing out of it. That's basically how it looks. Okay. So all the green stuff's filled in here. Like this is our little shaded region, I guess. This is all filled in here. That's how the shape looks. Okay. So this is what we're gonna do. We're gonna find the integral of the bowl, the volume of the bowl, and subtract away the volume of that like plug to get the overall shape. So let's start with the integral of the bowl, the outside part. I guess we better find some intersection points. This one should be pretty obvious, right? If it passes through the y-axis there, then it's going to be located at 0. And let's see, that'd be 0, 1, I guess. And then let's see, this point right here, that would be where the x value is 1, so 1, 2. That's where the green line and the blue line intersect, and then the red line and the blue line intersect at 1, comma, oh gosh, that'd be e to the negative 2 power. Okay, so first off, it's a disk problem along the x-axis, again, a horizontal line. That means that everything's going to be dx again. So we have outside integral minus the inside integral. Let's put this thing together. All right, so the green function is the outside integral, so that's going to be our line. So that'd be pi times 1 plus x squared dx. And then the inside function is going to be that e to the negative second power. So this is going to be pi times e to the negative 2x squared dx. And then the integral itself, remember, it's along the x-axis. It starts at 0, it goes all the way over to 1. So from 0 to 1 for all of those. And there's our volume right there. You just leave it like that. No need to evaluate it. All right, so there you go. That's the third disk problem. Now let's take a look at the fourth one. Maybe this is going to be another washer. I don't know. Let's see if it's 3 for 3. X to the third, y equals 8, and x equals 0. Oh, and this is around the line x equals 2. Ooh, so it's a little bit more complicated. Let's see how this looks. So x to the third, let's start with that part. So we've got x to the third. That's a cubic, so it's like this. And then the line y equals 8. It's like up here somewhere. So, we better find these intersection points like here and here and here. And I would imagine it doesn't say it, but like I bet it does have it. X equals 0. Okay, so it is surrounded by x equals 0. So that'd be the y-axis. So it's like this shaded region here. All right, so let's find these intersection points real quick. So let's see. The one up here, that's easy. That's 0, 8. And then let's see, this one's 0, 0, the origin. And then this one would be, let's see, where it intersects with x to the third and 8, that'd be 2. 2 to the third is equal to 8. So 2, 8 is the other coordinate. There we go. And where are we rotating this thing? So it's around the line. Oh, x equals 2. That's convenient, so it's like right there. Let me shave off some of this stuff. There we go. Let me put that last coordinate in there. Oh, I better move this over. Here we go. 0, 8, and 2, 8. There we go. And then it rotates around this line right over here. And that's located at x equals 2. And it rotates around this one. There we go. All right. So this is a disk problem. And, let me write in with colors the equations too. So that's y equals x to the third. And then y equals 8. And let's see. Let's rotate this thing also. So it would be like, oops, wrong color, red. There we go. Good. And then that line. And y equals 8. So it's like this shaded region. So here's how the shape looks. It's again like going to be a cylinder. That's what this like outside green shape looks like. Cylinder. And then we're going to take out like this red shape here. So it's like, it looks like this. Come on. Press red. There we go. So we're like taking this shape out of it. And so if we subtract it away, it'll end up with like a cylinder with that red shape taken out of it. So this will be like a hollow in here. So it's like all the other stuff is, the purple stuff. So like all this stuff in here, it's all filled in. Okay, just that one little hollow part. So we're going to subtract it away to get to that point. So let's find the cylinder first. And keep in mind that this is since it's a wash or a disk method, and it's rotating around a vertical line. That means we're going to be using dy in this case. So any equation that we have like this, y equals x to the third, we're going to have to actually write that in terms of y. So we solve for x. So x is going to be equal to the cube root of y. Okay. It looks like that's the only one that we're going to actually have to worry about. So no big deal. All right. So yeah, let's put together our washer. We better do the outside shape first. So that's the green one. So a cylinder. So along the y-axis, looks like we're going from 0 all the way up to 8, for this shape. So 0 to 8. And then for a cylinder, the radius is uniform. So the radius of the circles, the cross-section circles, are always going to be this length 2. So it's going to go like this. It's pi times 2 squared, and then dy. There you go. There's the cylinder part. That's this guy. We just found the volume. Next, we're going to subtract away the volume of this shape here. So let's see. It still goes from 0 to 8. It's still going to be pi times something squared, and then it's going to be a dy. This one's a little bit weird though, okay, the way that we need to write it up, because here's what's true about this. All right, so if I were to use this function, okay, this function right over here, the cube root of y, okay, that finds this length over here, okay, like this length each and every time. All right, but the thing is that for this red shape, I actually need like this radius here, for the cross section areas. So what I need to do is like kind of work that into, this radius part right over here. So what I need to do is this, like each and every one of these is 2 away um, from the center line, from the top to the bottom, 2 away. And so to find this little radius here, like this red radius each and every time, what I'm going to do is I'm going to take the number 2, so 2, that length 2, and I'm going to subtract away, these lengths that I get from the cube root of y. Okay, so minus the cube root of y, and that gives me my equation. That's like that's what happens when you have offset radii, or I'm sorry, offset axis of rotation. You just got to find that difference, or the sum in some cases. It's just sort of like it depends on each situation. You just got to kind of like work through it and find that difference. So there you go. It's 2 minus that. So I guess, okay, how can I put it? You're always looking for the radius from the center to the equation, but in some instances the equation is actually going to be on the opposite side of what you want. Like, so along the x-axis, like if I went out to like here along the x-axis, okay, that would give me this length here, okay, but I want the radius that's actually like corresponding to it, like over here. This is the radius of the shape that I'm trying to take out, the cross section I'm trying to take out. So to find that length, what I would do is I would take 2, which is that total yellow length, and then subtract away this little blue length here to get the radius that I need. So that's how I'd find this radius right here. These ones are tough unless you practice them a bunch. So make sure you do a bunch. I'm sure that we have a bunch of the homework. That practice the cases where you're rotating around something other than the x-axis or the y-axis, because those are kind of the easy cases. All right, so that's it for the disk method. Now we're on to the shell method, so I'll do a separate video for that one. All right, that's it for me for this one. I'll see you in the next video. So yeah, bye. See you then. Hasta luego.